Hi everybody, my name is Franca Garzotto from Politecnico di Milano in Italy, and I will present our research on interactive multisensory environments for primary school children. What is an interactive multisensory environment? It is a physical space that has computing, sensing, and actuation capabilities by means of connected digital devices embedded in the environments and in physical objects. An interactive multisensory environment enables multimodal, full-body interaction based on gestures, movement, and manipulation of physical materials, and provides visual, auditory, tactile, and olfactory effects that stimulate all senses. Our interactive multisensory environment is called Magic Room. The Magic Room has been designed for children with and without disability and has been developed in the context of Ludomi, a project of Polysocial, the social responsibility program of our university. In the Magic Room, children with and without disability can perform many game-based activities, individually or in group, with the supervision of their caregivers for educational or therapeutic purposes. Together with special educators and therapists, we have defined 8 design patterns of activities that address different goals, such as promoting cognitive and social skills, developing autonomy, or helping children to relax. At the moment, the Magic Room offers more than 100 activities that instantiate these design patterns with multimedia content and tasks at various levels of complexity. A unique feature of the Magic Room is its capability of empowering caregivers and children by enabling them to personalize the experience. Children can create their own visual characters and make them appear as animated avatars in the Magic Room. Caregivers can customize contents and complexity of each activity according to the characteristics of the children group. They can organize a sequence of activities within a session and control the experience flow at runtime, for example, stopping or repeating the ongoing activity according to the children's needs. The Magic Room is currently installed in 4 locations: 2 primary schools near Milan and 2 care centers for children with disability in Milan and Rome. One additional installation at a Center for Autistic Children in Milan is in progress and will be completed as soon as possible depending on the current outbreak. The following video describes the Magic Room installed at one of our local primary schools. Our current research focuses on exploring the effectiveness of the Magic Room in primary school education. We performed 2 empirical studies in the 2 schools where the Magic Room is installed, involving mixed group of children, that is, children without and with disabilities, and their teachers. The 2 studies had different goals. In Study 1, we evaluated the usability of interaction and of digital and physical content, and the children's likabilities of the activities. We also investigated organizational aspects such as the size of the user groups and the session duration for an optimal educational experience. In Study 2, we focus on the effect of the magic room for improving children's well-being and behavior. The participants in the first study included 39 children aged from 7 to 9 and 10 teachers. 22 children were neurotypical and 17 atypical. 21 were male and 18 female. We organized them in 3 groups. 2 were mixed group, one composed of 11 typical children and 8 atypical children, and the other composed of 11 typical children and 6 atypical children. The third group was composed of 6 atypical children only. Each group of children used the magic room 4 times, twice a week, along a 2-week period, for a total of 4 sessions. For the first 3 sessions, we predefined a set of activities, configuring them at a basic complexity level, and assigning the same activities to all groups. In the last session, children were asked which activities they wanted to do and performed the one they selected. For data collection, we involved 5 researchers from our team. They participated as observers during session and filled a structured paper-based observation form during and at the end of each session. They also managed the final focus group with teachers. In addition, children filled a likability questionnaire at the end of the 4th session. The questionnaire was designed according to a typical instrument used in empirical research among children, that is a smiley-o-meter on a 5-point scale. The observation during the session indicated that both children without disability and children with disability interacted easily with the digital and physical contents of the magic room, had no problem in performing the required gestures, movements, and manipulations. The focus group with teachers supported this observation and provided additional insights. Teachers suggested that groups with atypical children only should include no more than 4 subjects, while mixed groups could be much larger, up to 22 children, that is the entire class in Italy. Relaxation activities are particularly appropriate for large groups. In contrast, groups should be smaller for activities that involve many movements and action of multiple children, such as a grocery game. When groups are large or comprise more than 2 typical children, the presence of at least 2 teachers is needed. During the study, sessions lasted a minimum of 35 minutes and a maximum of 58. Teachers suggested that the optimal duration is 45 minutes, also considering that the typical classroom lesson is 60 minutes, and some time is needed to move from or to the classroom and to organize children before entering the magic room. The data from the questionnaires filled by children show the likability levels were good or very good, with score ranging between 3 and 4. The association and classification games had the lowest score, probably because they have less gamification features with respect to other activities. The grocery game and the immersive games were the most liked ones, probably because they exploit, more than the others, the multisensory features of the magic room. As shown in the table, a one-way ANOVA was computed to validate these findings, and a Bonferroni test was performed, which confirmed a statistically significant effect on likability for both the overall experience and the magic room, and 5 of the 8 types of activities. Moving to Study 2, here we explore 2 research questions. 1. Do the experience in the magic room affect children's well-being? 2. What is the behavior of neurotypical and atypical children in the magic room, and how does it evolve? In Study 2, we involved 68 children aged 7 or 8 and 12 teachers. 31 were atypical children, 37 neurotypical children. Children were organized in 7 groups. 6 were mixed group and comprised typical and atypical children. 1 group was composed of 2 atypical children only. To measure well-being, we adopted QBS A13, a standard questionnaire-based tool used in the Italian education system to assess perceived well-being at school. Children and teachers filled the questionnaire immediately before and after the study. To measure behaviors, 2 observers in each session recorded behavioral signals using a simple tablet application. The application was co-designed with a group of experts in pedagogy, psychology, and disability. They defined two behavioral signal schemas, one for atypical children and one for typical children. Each observer in the room focused on observing a specific population and recorded signals by tapping on items of the corresponding behavioral signal table in the tablet. We organized 4 sessions per group, 1 session every 5 days, along a period of 3 weeks. Together with the teachers, we predefined a set of activities at a basic level of complexity, differentiating the activities according to the group size and the subject cognitive level. The order of the activities was counterbalanced in order to ensure correct randomization. Concerning the results on perceived well-being, the QBS tool provides an aggregated measure called general score. The analysis of the difference delta between the values of the general score after and before the study shows a modest but significant increment for the entire population. Still, there are some differences between atypical and typical children. A typical subject manifested a significantly higher increase of their general well-being after the experience in the magic room, while the positive effect was less strong in neurotypical children. The QBS tool also provides finer-grained well-being measures on a composite scale addressing 5 different dimensions. For all children, the highest positive effect was achieved on the emotional attitude, the dimension that concerns with mutual empathy. Again, different results emerge when data analysis distinguishes between atypical and typical children. For typical children, we measured a significant improvement in 4 of the 5 well-being dimensions, namely relationship with teachers, relationship with peers, satisfaction, and emotional attitude. For neurotypical children, only the value of emotional attitude improved significantly. Our analysis of behavioral data highlights that for all children, the level of engagement was high and was maintained along the time, regardless of what was happening in the magic room. There were no relevant differences between sessions. In addition, all children manifested a higher number of positive behaviors with respect to negative ones. Some behavioral differences emerged between atypical and neurotypical subjects. In general, the variety of behavioral signals was smaller in atypical children with respect to the other children. This might be related to the behavioral and cognitive rigidity that is associated to many disabilities. Still, new positive behaviors emerged along the time, highlighting that the magic room experience might have a stimulating effect on unlocking rigidity. In the first session, atypical children manifested stress and anxiety. These findings are consistent with the characteristics of this population, for whom any novel situation is intrinsically complex to manage and increases the cognitive load. Still, stress tended to disappear with time, also when new activities were proposed. According to teachers, the progressive relaxation seldom occurs in classroom activities, and indicates that children felt progressively more comfortable and more engaged in the magic room. In summary, our research has explored the use of the magic room in real educational settings for mixed group of neurotypical and atypical children, performing 2 empirical studies involving in total 107 children, 45% of them atypical and 55% neurotypical. We evaluated the usability of the magic room and explored its educational benefits, highlighting 2 main aspects. First, the magic room seems to be usable and engaging for both typical and atypical children, organized in large or small groups. Second, even a relatively short experience in this interactive multisensory environment might influence positively the children's well-being, behavior, and mutual empathy, and ultimately improve inclusion. In addition, in our studies, we elicited some organizational guidelines that might be helpful for the school adoption of the magic room, as well as other interactive multisensory environments. Investigating complex technologies in real educational contexts is always difficult and challenging, and our empirical studies certainly have several limitations. Still, they are unique for their design, duration, number of participants, and the characteristics of the children involved. Our overall findings, although preliminary, suggest that interactive multisensory environments like the magic room have an educational potential for inclusive education, and we hope that our research could inspire future studies from other researchers in the field to confirm this potential. Thanks for listening.